Why AI chatbots is so profitable feels normal, but it is rarely accidental, and the structure behind it dictates the survival of the business itself. To understand the shift, you have to look at traditional software as a service. Once the code is written and the servers are live, the cost of adding one more user is effectively zero. Replicating the product doesn't require more labor or more materials. This chart shows the result, a flat cost line against climbing revenue. It's why mature software companies can consistently hit 85% gross margins. At scale, the revenue detaches from the operational cost. Most analysts assume AI chatbots follow the same trajectory, but trying to run a generative model on a SaaS budget creates a structural financial trap. This is the inference tax. Unlike traditional code, an AI requires massive GPU compute and energy for every single typed prompt. The software isn't just sitting there, it is actively performing a calculation every time a user hits enter. Because compute costs scale linearly with usage, active users can actually become unprofitable. This dynamic is currently compressing AI gross margins down to an average of 52%, a far cry from the software gold standards of the last decade. If usage drives costs up this sharply, logic suggests that massive adoption should bankrupt these companies. Instead, they are seeing record-breaking revenue and conversion. The solution is the data flywheel. This self-reinforcing loop means using the product generates value to offset costs. It begins with human behavior. A recent study found frequent chatbot use is linked to deepened feelings of loneliness and growing emotional dependence. This dependence ensures a steady stream of data. Users don't just give short commands. They type detailed, highly personal, and nuanced prompts for hours on end. This sustained psychological engagement provides the high-volume proprietary data required to keep the flywheel spinning. Millions of messages are ingested back into the model's architecture. Every interaction becomes a training sample, helping the system map more complex structures of meaning. In the model training node, the system refines its responses autonomously, identifying successful patterns in real time. By automating the repetitive work of refining the model, as the AI becomes more reliable, they move away from per-seat pricing. They transition to outcome-based pricing, charging for a specific result, like a resolved support ticket or identifying a churn risk. This chart shows the transition's impact. Tying price to value drives a pilot-to-paid conversion rate of 56%, nearly double the SaaS average. It slashes customer acquisition costs by half because the product's performance drives its own adoption. Under this model, the inference tax is neutralized. The high usage that once drained the company's margin now generates the exact outcomes that the customer is willing to pay a premium for. This creates a divide between AI-powered legacy tools, which simply bolt a chatbot onto old human workflows, and AI-native companies, where the AI manages the data and the workflow autonomously. This is the Jevons paradox in action. As AI tokens become 1,000 times cheaper, organizations don't save money. They use the resource 5 times more often. Total consumption spikes because the intelligence is now cheap enough to embed in every single digital task. AI-native companies are architected to capture this surge. They lock high usage into a cycle of automated data ingestion and outcome-based revenue. These organizations have built a distinct economic architecture, one that legacy competitors cannot simply replicate by adding a fresh coat of AI paint to an old system. The perceived gold rush in AI profitability is only visible when you see how human psychological needs and high-fidelity data pipelines are being woven into a single, unified machine. So the effect is not random, it is structural, and now you see it a little more clearly.